Welcome everyone to Genesis and ModelCenter for MBSE 2.0, presented by Scott Ragon, Mark Malinoski, and Mark Simons. My name is Donna Long and I will be your host during today's webinar. Dr. Scott Ragon holds a PhD in engineering mechanics from Virginia Tech and has over 25 years of engineering, modeling and simulation, and design optimization experience. Dr. Ragon joined Phoenix Integration in 2004 and is currently the Director of Technical Business Development. In addition to helping to define Phoenix Integration's technology roadmap, he acts as a strategic technical advisor to Phoenix customers and is responsible for assuring that customers are successful with Phoenix products and services. Mark Malinoski is a technology and business manager with more than 30 years of experience in engineering, marketing, and general management. His expertise is the development and launch of leading-edge technology products to global market segments. Mark has been part of high-tech production and metrology equipment firms such as Schlumberger, JDS Uniphase, Advantest, and Tektronix, and has spent 10 years as an independent consultant. As a technologist, Mark holds 6 patents and has been published in major technology forums. Mark Simons is a principal systems engineer at Vitech Corporation, where he is responsible for consulting and training functions. Mark has over 25 years of experience in the systems engineering of space, aviation, telecommunication, and defense systems. He has received multiple awards over the course of his practice for his previous work at MITRE and NASA. Mark has also taught topics in systems engineering for the Johns Hopkins Whiting Engineering for Professionals program. Before Scott, Mark, and Mark get started, I have just a few housekeeping items. They will be answering questions at the end of the webinar. Please send your questions in as soon as you think of them through the question tab on the webinar control panel. They will answer as many questions as they can today, but if they do not get to your question, we will reach out to you after the webinar. The webinar is being recorded. If you experience connection problems during the live presentation, a recording will be made available within 1 business day. The recording will be published to Vitech's webinar archive located on our website. At the conclusion of this webinar, a survey will open on your screen. Please take a moment to give us feedback on today's presentation or on what topics you would like to see covered in future webinars. Now I'm going to turn the presentation over. Welcome, and thank you for joining us.
Thanks, Donna. If you've joined any of our previous recent webinars or presentations, you've heard us speak about MBSE 2.0, the concurrent connected engineering of systems. This is our view of the progression of the state of the art of model-based systems engineering and the manner in which we can meet the challenges of complexity and cycle time collapse that continues in many industries. Simply speaking, it is moving model-based systems engineering to a bridge across the entire product life cycle. And in doing so, systems engineering becomes a much more central theme in the overall engineering enterprise. The system design and architecture that we produce will enable much broader participation of the different team members across the enterprise throughout the program lifecycle. We frequently reference a quote by General McChrystal in his book, Team of Teams, that functioning in an interdependent environment requires that every team possess a holistic understanding of the interaction between all the moving parts. We feel this quote directly falls on the challenges in front of us and how we'll need to build fit-for-purpose engagements by many more members of the enterprise to contribute to the implementation of the system of interest, as well as support the engineering enterprise to deliver it. Now, to meet that MBSE 2.0 challenge in enterprise performance, the foundation of that is going to become what we call the systems meta model. Now, the systems meta model has been with us for many decades. Its origins stem back to the late 60s and the involvement of TRW with the DoD and NASA. And it's progressed to become an industry-proven methodology for designing and decomposing the system designs. What's unique about it is it's in the natural language, so it doesn't require specific syntactic skills to be able to understand the system designs. It's represented in 100% explicit data that resides in a database so that multiple types of views and representations can be derived from it. To be able to achieve that, we have to, in that explicit data, cite what types of relationships can be made between all of the entities or class instantiations that we use to describe the system design. And you can see here that different types are color-coded as they play different roles in the system design. Now, we're going to be focusing in today on a portion of the systems meta model that enables the physical analysis interoperability that we're going to be describing in this webinar. Important in that is the constraint definition class and how that interacts with the verification of requirements. So we'll be spending quite a bit of time on these class types as we move through this webinar today. So if we look at how we do behavioral and physical analysis across the engineering V, we need to accelerate verification and traceability to help us achieve the goals of MBSE 2.0. Not only do we have to do that for the first iteration of the target system of interest, but as we operate these target systems in the usage domains and continue to improve them, add features, make upgrades, improve the way they are maintained, we'll have subsequent smaller in scope iterations of the same engineering V. How those later in program life cycles will deliver those upgrades in in concert with the complexity and accelerating cycle times we're facing is going to take strong advantage of how well that first systems model for the target system of interest was implemented. So being able to do so in such a way that the model captures the design well and captures the why of the architectural decisions and how those aspects of the architecture are verified becomes critical. Behavioral analysis will become much more important. The Vitech tools are particularly strong in this area. We spend a lot of time in our training in guiding how we do behavioral architecture and how that is verified by our discrete event simulation within our tools. Also becoming important then is how, as the design progresses, at the component level, how do we do physical analysis of those designs? How do we do that simulation and analysis so we can bring that back early and start verifying requirements at the component level? This webinar is going to focus on that aspect of how the GENESYS tools will interoperate with physical analysis to achieve the MBSE 2.0 level of performance. So with that, I'd like to turn it over to Dr. Ragon to give us a brief overview of Phoenix Integration's ModelCenter MBSE product, and that'll serve as some context for our discussion on how we interoperate. Dr. Ragon?
Okay, thank you very much, Mark. So I'm sure many of you on the webinar today have gone to see a symphony orchestra before. And if you have, and if you're like me, you may have been a little bit surprised about how much attention one of the people on stage gets. Next, Mark. And that person that's getting all the attention, if you've ever been, is the conductor of the orchestra. And it seems perhaps a little bit strange when you first see it, because the conductor is not there to play an instrument. In fact, he or she's the only person on stage who isn't. And by the same token, the conductor's not there to teach anyone on the stage how to play their instruments. Everyone on the stage is probably spent their whole life mastering that instrument. So that's not why the conductor's there either. But I think we all intuitively understand that despite all of this, the conductor is important. The conductor is important trivially because the conductor decides what piece of music everyone is playing. But more important than that, way more important than that, is the conductor really is there to make sure everyone on the stage is listening to one another, that everyone has the same interpretation of the music and is on the same page about that. And when that collaboration works well between the orchestra and the conductor, the results can really be fantastic. So my question for you is, what if you had a conductor for your engineering, design, and analysis team? What if you had someone to coordinate all the different software tools that your team uses to do analysis, to do design, and someone not just coordinating the tools, but coordinating all the data that flows between those tools and coordinating the people who use those tools? If you had that, that's going to result in more efficiency for your team, a reduction of errors, and overall, your team's going to be able to work together to come up with a better, more innovative design. So that I'm describing here is really what ModelCenter is all about. Next. So ModelCenter is a framework that helps your engineering team work together more productively and resulting in better designs. And just like the conductor is not there playing an instrument, ModelCenter is not an analysis tool itself, but ModelCenter is a framework in which to coordinate the activities of all the other things going on in your organization. So what is ModelCenter really about? Next, please. So ModelCenter consists of three main capabilities. The first and the core capability we call ModelCenter Integrate. And ModelCenter Integrate is all about taking all these simulation tools or software programs or databases, what have you, all throughout your organization, integrating the individual tools, and then giving you the ability to connect those up together into a multidisciplinary workflow. And then ModelCenter can help you execute that workflow over and over again, eliminating errors, making you more productive. The second stage, next animation please, is ModelCenter Explorer. So ModelCenter Explorer says, okay, now Integrate has allowed you to create an automated workflow, engineering workflow. Explorer helps you run that workflow over and over again to help you learn about the system that you have modeled and help you make better decisions about your design. So it includes things like design of experiments, like sensitivity studies, visualization of the design space, optimization, Monte Carlo, all those things are in Explorer. And then the third item, next, and this is where we'll really focus today, we call ModelCenter MBSE. And ModelCenter MBSE is the piece that connects your workflow that you created with Integrate and Explorer with Explorer, connect that to the systems model, to connect that ModelCenter workflow to Genesis. And next slide, please. And so ModelCenter is the piece that helps you tie together all your analysis tools. And these can really be anything you want them to be. Excel spreadsheets, MATLAB scripts, Python scripts, a FORTRAN code someone wrote 20, 30, 40 years ago, together with today's off-the-shelf tools, CAE, CFD, CAD, all of this, helps you put these together in any combination that you want to analyze your system. Next. And so, as we've said, ModelCenter is the framework that allows you to do that. ModelCenter helps you put all these together, and we talked about Explorer over on the right-hand side there, multidisciplinary analysis, optimization, trade studies. So what we're talking to you about today is using ModelCenter to put together engineering analysis. And what we're going to do is connect that engineering analysis to the systems model. Next, please. And so we're going to build a bridge between Genesis and ModelCenter to help the systems engineer validate requirements and optimize the system design in whatever manner they want to do. So next, please. So what we're going to demonstrate today is we're going to show you how you can connect engineering analysis tools, whatever you want, to Genesys in order to do a better job of systems engineering, to validate requirements early in the design process, and then continue that process as the system design matures. The ultimate benefit is helping you to find mistakes in the system design earlier when they're pretty cheap to fix, at least relatively cheap to fix, and then helping you to continue to do this throughout the system lifecycle, reducing schedules, reducing cost, and ultimately reducing the risk of these complex systems. So that's what we'll demonstrate today, and I'm going to turn the floor back over to Mark then.
Thanks, Scott. So with that, we'll delve a bit deeper into the model that we're going to be using today. I'm sure it's familiar to many of our participants. It's a vehicle braking distance or stopping distance model. And we are going to be focusing on analysis as it pertains to the stopping distance. So if you look at it just in the requirements diagram around the stopping distance, our vehicles specifying that requirement, and then it's going to be verified by both an analysis as well as a measured demonstration. We're going to be focused on the analysis portion today. If you look at the block definition diagram, you can see that the vehicle consists of an engine, a transmission, something called wheels, which then breaks down into the brakes, the tires, and then under the braking system, we have the calipers, the pads, the rotors. So our analysis is going to be focused on the components down in these areas and the associated parameter space associated with those components. So a little bit about using parameters in Genesys. For those of you that have been core users of the past and possibly migrated to Genesys or considering migrating to Genesys, you may be familiar with parameters. Parameters can be assigned to any or defined for any entity type in the schema. By selecting any entity type. So here we're selecting the requirement stopping distance, and we go to the parameters tab, and we can see we've got some parameters defined on that particular requirement called stopping distance. Now in Genesys, there is a predefined set of parameters, and then you can create new ones as needed. But the parameters that are predefined inside of Genesys are broken out and grouped by those that we felt were relevant to the different entity types. So if you were to start to manipulate the add remove capability of the parameter tab, you would see the opportunity to pick through this list of entity types, and you would see an associated change in the predefined ones that are available. Now, what you can do with those as you define them is you can use these as variables in the text fields. So in the description blocks or other types of text fields, you have the opportunity to do the right-click menu pull down. You'll see this option to insert a parameter, and when you select that, then the parameters that have been defined for that particular instance or particular entity appear available for you to select from. Now, once you start using those parameter values then get resolved in not only in the display of those text blocks, but also in reports and associated views. So here you can see we went into the reporting toolkit and just pulled up the requirements hierarchy report, and you can see that the stopping distance requirement has been resolved to the values that have been specified in the parameter tab. Likewise, when you roll over diagrams that you generate within Genesys, you can see the description of those entity being displayed with the parameter values resolved in the text as well. So this becomes a very powerful tool, these parameter capabilities, to variabilize the different text and descriptions and reports, etc., in your system model. So let's look at parameters in requirements traceability. Here's an example where I might be using the Excel connector. If many of you have had experience with the cell connector, it's a very popular connector feature within Genesys. And in terms of reaching to that MBSE 2.0 kind of performance, where we're trying to engage, many contributors in the team across the life cycle in a fit-for-purpose way for their roles, the Excel connector is a great enabler of that. So in this example, we've pulled up the requirements table, and here we've added the stopping distance to that particular table, and we can provide that to the test engineer that's doing the measurements or on the observed value of that particular parameter. And once that change in the Excel spreadsheet using the connector is published back to the model, it would show up in the observed column of the parameters. So here we can see the strength of having these different contexts for the parameter values. We have the objective, which is sort of the ideal goal for the particular design solution, a threshold, which would be more of a go no go kind of constraint on the system design. Then, as we'll see later, as we bring back design analysis values from ModelCenter, it'll populate in this column, and then the observed column is intended to be used for the actual prototypes that are being measured. So across this context of the different values for these parameters, you can see how we start to build up knowledge of the verification paths that we're taking as we completely meet all our traceability requirements. So parameters and constraint definitions. And this is something that Genesys goes beyond core in that we have the constraint definition class, and that constraint definition class adds some specific relationships to the system's meta model for the purpose of enabling analysis. The two relationships that are most significant are the constraints or constrained by relationship, as well as the uses parameter or parameter used in relationship. So those two bidirectional relationships are significant to the constraint definition and mainly are used to target functions, links, components, and items. So there are some relevant similar entity class types that are more at the enterprise performance level that can also be used as parameters to interact with the constraint definition entities as well. But these are the main 4 class types that are significant to system of interest designs. So you can see that in this very simple example, if I looked at the attributes page of the properties tab for just a function, you can see that it's been constrained by the constraint definition called just a constraint, which is this entity here. Likewise, I can see if I did something similar for the entity just an item, I can see that it's also using a parameter from just a constraint definition. So this is also an example of in Genesys where the interoperability between the forms interface and the diagram interface becomes very, very useful. Something that's fairly unique to the Genesys tool set and is the Vitech tool set and is derived from our architecture around the system's meta model and the explicit definitions of these relationships. So that's how constraint definitions and parameters interact between the different entity types. Now, if we look at that in terms of a parametric diagram and more to the specific model we'll be working with today, we can see how the constraint definition has the expression and defines the independent and dependent variables associated with that. And now you get the sense of how we're building up the details by which we're going to pass over these analysis requirements over to ModelCenter. Likewise, you can see similar information in a parametric view. Here we see the caliper analysis and the expression for the dependent variable of the normal force and how these different components are contributing to it with the various independent parameters that are involved. Likewise, you can see down here the relationships that are being associated between this constraint definition and the entities that are contributing to the analysis. Now, this is the full parametric diagram of the model that will represent the analysis we're doing today. I've got it split down the middle just to help it fit on this screen. So you can see that our stopping distance analysis is being contributed to by a number of different parameters, mainly from the vehicle definition and the tire definition. And then the pad analysis is being contributed to primarily by this caliper analysis. So we'll be working with how we manipulate the normal force of the calipers as it relates to the pad analysis and the stopping distance. So once we have all the system design in place to enable us to perform this analysis, then by selecting the Utilities tab, and this changed a bit with Genesis 7.0 and the introduction of the ModelCenter Connector. So by selecting the Utilities tab, you get the opportunity to start the interoperability with the specific connectors. And here we see the Phoenix ModelCenter connector, and that's the one we'll be clicking on to start the configuration of ModelCenter and to start doing some analysis within ModelCenter. So with that context, I'm going to pass over to Mark Simons, who's going to actually walk us through a demonstration of Genesis and ModelCenter interoperating. Mr. Simons?
Okay, great, thank you. Let me share my screen here. Everyone seeing that? Very good. So I'll just review the model here that I have. Mark did a great job giving you the details here. We'll be exporting some of the parameters and data from this model over to ModelCenter MBSE. As Mark pointed out, our entities here will have the parameters, and the values here, the design parameters, are here mentioned in the objective field. And in some cases, we'll have some parameters that have both an objective and a threshold. Genesis will interpret these parameters either as design input parameters or as requirements, depending on the types of relationships you have. So for example, we do have a specified relationship to our stopping distance requirement that helps connect these parameters to that requirement. And just to kind of review here, so we'll be exporting these values over to ModelCenter MBSE. We've got some values here for our brake coefficient of friction, our center length, for example. We'll have some values here for our tire, the diameter, wheel speed, and a tire coefficient of friction. We'll be exporting these component information. Mark mentioned the constraint definition. We have a stop distance analysis constraint definition that we'll also be exporting. And you can see the expression here that Mark demonstrated and discussed earlier with the variables mentioned here. And as Mark mentioned also with the targets and attributes, we can connect those variables to the parameters that we've been defining. And of course, we have the requirements here as well with their parameter classes that are also have been defined. And then when it comes to the workflow, we wanted to kind of show how we can use Genesis to do verification and validation. What we do is, according to our systems meta model, we create an entity here, a verification requirement that will verify our stopping distance. And within that description, we describe how we're going to go about that verification and what type of analysis we'll be doing. And then we also have some parameters here that are available to us, or some attributes, excuse me, that help define that. So we have a status attribute, a method attribute, and a level attribute that we can all define. And so we're going to kind of conduct this test now. We have a test that's planned. We're going to conduct it by analysis, and I'm going to change this value here to in progress to kind of demonstrate the work that we'll be doing. And this verification requirement is tied to a verification event that I'm calling the stopping distance analysis that we'll be doing now right shortly. So now let's go fire up ModelCenter MBSE. Before we do this, we have to ensure that we have ModelCenter Analysis Server, the Phoenix Analysis Server product up and running and configured and running in the background. When you have that in place, we can now go ahead and invoke ModelCenter. When we do that, we have some choices on what we want, on how we want to export information. In this case, I'm going to be exporting all the requirements, constraint definitions, and requirements in the full model. You can limit those to elements within a particular package. You can see here I've got some defined. With the custom option, you can access subfolders, specific folders or subfolders, or root entities actually. And with the existing file, you can access some previous analysis, and I'll be demonstrating that later in the demo here. All right, so we're going to be exporting our components here with entity number and name, same with our requirements, and now also with our constraint definitions. And we'll confirm that, and we'll get this firing up. Okay, so now we have ModelCenter MBSE up and running. We have an execution plan that's come up as default. Right now in the center panels, we have everything's empty now. On the right-hand side, we can see where our information from Genesis has arrived. We see our component elements here, the vehicle, the engine, the wheel, even our brake. We can see the actual parameter names that have come over. In our analyses, we can see that we have the constraint definitions for stop distance analysis that's come over. Cost analysis has come over as well. You'll notice that we also have some other analyses here called requirement analyses. And these analyses have been generated automatically by Genesis by interpreting the threshold and objective values as requirements, and then also creating an analysis that will allow us to determine whether our results in fact meet requirements. And then the actual requirements themselves come over as well, listed here. All right, so we're going to, at this point, demonstrate a simple analysis that we're going to do with our stop distance analysis. When I pull this over, this is similar to what we've shown in previous webinars with a short video. When we pull that analysis over here into the center panel here, you see that the parameters have been identified as well as their values. So we can see that brake diameter and tire coefficient has come over as 0.9 values. We can see some of these other values here are familiar from the parameters we examined earlier. And when I examine this and analyze it, I'm going to also look at how we do with validating our requirement. We want to stop, if you recall, less than 180 feet. Our objective is 160, but our threshold is 180. So we're going to run this model now simply by clicking the run, and we'll kind of come out with some analysis that results from this. And we can see here with the check mark that our requirement has been satisfied. We can look at the value itself to determine exactly what came out of the analysis. You can see with the blue arrows are telling us what our results are. The green arrows are are the inputs. So we can see here with stopping distance, we had a threshold value of 160 or an objective of 160, and we even came in less than that. So just based on pure design parameter information that came from Genesys, we can show that we have, in fact, met the stopping distance. But this analysis is early. It's not complete. We haven't really modeled our caliper at this point. We haven't really modeled our brake pad. So what we want to do to fully verify this requirement is incorporate these other elements of our design. And so the way we do that is we want to add some more information about our analysis of the caliper and the brake pad. And so what we're doing is we're imagining now that we have an engineering design team. We're trying to connect our enterprise like Mark described in our vision of MBSE 2.0. So we have an engineering design team that has used some third-party tools to do some sort of analysis to be able to calculate caliper values and brake pad values. And so we want to incorporate those in here. So what we're going to do is create a new analysis. And we're going to go out onto our network and find where that design team placed their analysis. And in this example, I am going to go look at my local hard drive. Oh, there it is. And I can see that I have a number of analyses here analyses that are available to me to add and complement to my analysis that I've brought in over from Genesys. So I'm going to bring this caliper model here to show you how to connect this up. So this represents the variables here on the right hand side that our design engineers have come up with as input parameters for their caliper model, and it shows that they're going to be calculating a normal force for us. And what we have to do here is map our Genesys parameters to these analysis variables. So we have a caliper. I'll go look for our caliper parameters, and fortunately you can see that the names are very similar. I'm going to map the diameter to a piston diameter, the friction force, the normal force here to normal. You can see here, because of the direction, since it's an output, the arrow is reversed. Pressure, and finally spring force. All right, so that's simply how you make this connection, and this is just making this orchestration now between Genesys and our third-party analyses. All right, so I want to hit OK. And you can see we got a caliper analysis. Now, we, as Mark showed earlier with the parametric, we know we also have a pad analysis that we need to incorporate as well. Now, I can go ahead and create a new analysis like this and create a new one for pad analysis, but it turns out there's quite a few parameters in pad analysis. So I am just going to quit what I've done here and invoke ModelCenter MBSE again, but with an existing file that I've implemented previously. So this is a handy way of saving your work and picking up where you left off. Okay, so you can see here that I have another execution plan called Brake Demo. I've used it to with the vehicle stop distance analysis, and you can see that I have a caliper analysis that I brought in, and also the pad analysis. Just to kind of show you what this looks like, you can see that the mappings have been done here to the brake pad. And you can see that in addition to the brake pad, it's pulling in variables from other parts of the model, such as vehicle speed. Okay, so now we're able to do some more analysis. We can bring in a model of our caliper. We can bring a model in of our pad. And as before, we'll bring in an analysis of our requirement. Now we're actually now being able to incorporate third-party detailed engineering into this analysis to see how a final design will will work and whether or not we can meet our requirements. So we'll go ahead and run this. And what we see here is that we get a red X. We look and see that something's happened now with these parameters that are being calculated. And we see that our stopping distance is actually increased. We no longer even meet our threshold requirement of 180. So we have to put on our thinking hat as engineers, get design teams together to figure out what it is we may need to adjust in our design to meet this requirement of stopping distance. And in this case, what I'll do is I'll go back to our execution plan and make the decision to increase the pressure of our caliper. I'm going to move that up to 1,000 PSI. We'll make that design decision, and then we're going to rerun this analysis with that adjustment. And now we see that, in fact, we can meet our design requirement. We can get back to under 160 and meet our threshold. So this is now an example of, a validation and verification of the stopping distance requirement, making use of physical models that we've imported from Genesys and parameters we've imported from Genesys, but also taking advantage of our MBSE 2.0 digital engineering environment within our organizations to connect the enterprise. And so with this, we can save these execution results back to our model. And then we can go back to our workflow, go back to our verification requirement. Excuse me, I always want to do that. There we go. And so we are now complete. We are complete and satisfactory. And we can also go ahead and document this effort with a stopping distance analysis document that would help us document that. And with this document, you can see that I've even tied it to our stop distance file that I saved from ModelCenter MBSE. So that's the round trip here. I'll turn you back over to Mark and to wrap up and for any final questions.
Thanks, Mark. So in summary, what we've shown you here today is how physical analysis can accelerate and improve requirement verification earlier in the progression of the development of the target system of interest. As we're advancing component level design, we can now bring in physical analysis and start to build up more knowledge of not only why the system architecture is the way it is, but how component level detailed design is implementing that, and any trade-offs we've had to make through the process of multi-domain detailed design to realize the source level requirements of our system. So by doing that, we're building up knowledge inside the system's design and the model of the system design, not only for the details of the system design itself, but why the team chose to make certain design decisions, certain trade-offs, and all the associated data can be referenced as part of that verification chain. That will then capture that for later use of performance upgrades, etc., so that as team members change, we're relying on the commonality of practice that our systems meta model approach gives us, the design data consistency that results, such that we can start to not only capture that know-how inside of the system design, but also make it readily available for ongoing iterations through the life cycle. So with that, I'll turn it back to Donna, and we'll take any questions that you have.
Thank you. We do have a few questions, thanks to our participants. I encourage you to join the discussion now and submit your questions using the webinar control panel. If you do need to If you do need to leave the webinar, please take a moment before you go to respond to the quick survey that will pop up on your screen. Our first question comes from Tony. What software tools can be connected to Genesys using ModelCenter MBSE? And I think we'll let Dr. Ragon take this one.
Okay, thank you, Donna. Yeah, as I referred to in my introduction to ModelCenter, ModelCenter really is a general purpose framework that can automate any engineering software tool, any engineering application at all. So that includes scripts, old executables, FORTRAN codes, if you will, Python scripts that were written yesterday, and a whole variety of off-the-shelf tools like Excel and MATLAB, as well as finite element tools, CFD tools, CAD tools. And so we provide a general framework that really will allow you to automate anything you want to automate. And our training class, you take our 2-day training class and you can go back and automate just about anything. And anything that has an API is easy. Anything that reads and writes files is easy. And I've been at Phoenix now 15 years, I guess, and I've yet to see something that we couldn't automate. And most of our customers automate them themselves, so you don't have to come to us or have us do any services for you. We give you everything you need to do it yourself.
Okay, I think we'll stay with you, Scott. The question is from James, and it's does ModelCenter allow for searching for the optimal solution?
Yes, absolutely. In my introduction, I talked about ModelCenter Explorer, and part of ModelCenter Explorer is optimization capability. And what that means is you can set up a problem and pose it to the optimizer. So for example, you can say, I want to maximize this performance characteristic. So maybe I want to maximize the range of an airplane that I'm designing. And you can tell it, change these variables and find the values of these variables that maximize range. At the same time, you can say, well, I do have some constraints though. So I want to maximize range, but my budget is this, don't exceed this much. Don't let the cost go over this target amount. And you can continue in that way, describing the variables that you will allow the optimizer to change, describing what your goals are in terms of minimizing or maximizing certain properties, and in terms of applying constraints. And we have a whole variety of different optimization algorithms that then can be run to try to find the answer to your question. So find the values of your design parameters that maximizes the range without spending anything over your budget. So that's a very common use of ModelCenter Explorer, and this connection with Genesys gives you the access to all of that capability.
Okay, so this question says, once you do an analysis, can you then go back to MBSE tool and see updates to the architecture?
So I'll start with that, and you may want to chime in, Mark. The values that we're optimizing typically are the values that are in the SysML model. They're not really architectural details, but they're the values that describe the various blocks in the SysML model. And you may be able to put that better, Mark.
Yeah, if you recall, we have a number of different contexts for values associated with the parameters we defined. One of those was the design context. It was the third column over, left to right. And we may have glossed over that in the demonstration too quickly, but some of the values that were resulting from the analysis were actually being written back into that design column that would then be captured in why we determined that we can mark the requirement as met satisfactorily. So those values are written back, they are captured, and then any associated commentary in notes or documents that we want to associate with that verification of that requirement becomes part of the traceability.
Thank you, Mark. Okay, so the next question is, does ModelCenter Connector, is the ModelCenter Connector only supported by Genesys 7.0, or is it supported in earlier versions?
Yeah, the Genesis 7.0 was the introduction of that connector. So it is required that you get to Genesis 7.0 to be able to take advantage of this capability.
So a follow-on question is, does ModelCenter Connector require a separate license to run?
Scott, can I let you take that one?
Sure, sure. So if I understand correctly, the connector created by Vitech does not require a license. However, the ModelCenter MBSE connector that connects ModelCenter to Genesis does require a separate license. And if you want to learn more about that, just contact anyone at Phoenix and we'll help you out.
So the next question is from fromTikka. I apologize if I'm mispronouncing your name. How is ModelCenter MBSE different from MBSE PAC?
Very good question. So ModelCenter MBSE fulfills the same overall functions that MBSE PAC does. MBSE PAC is Phoenix Integration's older product, and it's being superseded by ModelCenter MBSE. ModelCenter MBSE is a complete rewrite from the ground up based on what we have learned from our customers around MBSE PAC. So it has the same basic functionalities, but it's rewritten to be easier to use. Defining constraints, for example, is much easier. And I hope you saw the interface today. I think it's a big improvement over what we had with MBSE PAC. So going forward, as of today, you can use either product in general, but ModelCenter MBSE, and then specifically the connector to Genesis, is based around MC MBSE only. And so that's where we are transitioning our product line in any case. And so this is built around our latest technology.
So we have another question from Chris. Can ModelCenter MBSE be connected to Riverbed Modeler for network modeling?
So I'm not familiar with Riverbed Modeler. If it's an analysis tool, we can take that and integrate it into ModelCenter, and then via ModelCenter connect it to Genesis. If Riverbed Modeler is more of a systems modeling tool, that's a different question. So could you clarify, if you would clarify the question, I can answer it more completely.
Okay, I'll look for Chris to respond with that. Another question that probably comes right from there is, can we use ModelCenter MBSE be connected to Cameo?
Yes, it can.
Okay. From Edward, I expect the tools can be used with third-party software to write specifications, including allocations, flowdowns. Am I correct?
Mark, I think that's more of a question for you.
Yeah, I guess I would want to have a bit more detailed discussion about that. I think generally the answer is yes, but I think a bit more context. If you want to follow up with us afterwards, drop me an email and we'll make sure you got a complete answer on that.
Okay, I'll look to see. We'll probably have to respond offline on that one. So the next question is there a way to look at optimal results over time? I want to look at how we progress in the improvement of our model over time.
I think that's something we'd have to look at more closely. These workflows are relatively new, and what our users our common users are going to try to do with them is still work for us to do together. I think certainly that kind of capability is something that we could probably do something to assist with. It's not immediately obvious to me what that would be, but we'll certainly take a closer look at that and see how we might best address that. And then, how we could improve and automate the ability to do that would be something we would want to attack in future improvements to this capability.
Thank you, Mark.
That's a great question, by the way.
Yeah. I'm just looking through theirs. Okay, Chris got back to us. Riverbed Modeler is a discrete event simulator for evaluating performance of networks and network protocols.
Okay, okay. So that would be something that we could, ModelCenter could integrate that tool. And then via the ModelCenter MBSE connector to Genesis, we could make you could feed values from the systems model to the tool and then get the results back and feed them back to the tool. So short answer is yes, you can connect that into this ecosystem.
So another question from Jimmy is, could you automate changing the verification requirement status based on the results from ModelCenter MBSE?
Wow, that's a good question. I would say right now, no, and maybe that from a methodology standpoint, you don't want to automate that. I think it really comes down to what is your methodology for requirement verification and traceability. In our way of thinking, that is something that at a systems engineering level you would want to scrutinize and be able to capture the associated why of how you determined that you have met that requirement satisfactorily. Now, could you consider having your methodology so well defined that the collection of support data that is adequately justifying that that definition of why that requirement was validated? There may be ways to do additional scripting today in Genesis to enable that. As you may know, Genesis is a .NET compliant application, so all of the scripting tools from the .NET environment can be utilized. And our API is very well defined and supported, and people are having great success with it. So I think there's a way to get there and start to improve on more sort of power tools in checking off verification requirements.
Thank you, Mark. We have some technical questions here from Jimmy. Can the GNMC file be opened in text editors for people who do not have access to ModelCenter MBSE? From my aspect, it really would not make sense to do that. It's simply a ModelCenter model. Maybe Dr. Ragon, you can talk about what kind of data would be in there, but I don't think it would be useful to open that file.
Yeah, Donna, I agree with your answer.
Okay. Let's see. We got time for a couple more. If you have any other questions, please do send them on now. Like I said before, if we don't get to them, we will reach out after the webinar. So question from Bill, what data can be sent back to Genesis from ModelCenter? For example, when the caliper pressure changed to 1000 PSI, is that automatically pushed to Genesis or requires manual changing?
So it's not automatically pushed, but you may have seen in the demo at a certain stage, Mark pressed a button that said, to update the system model. And at that point, that's where that value goes back to Genesis. But we didn't want to do it automatically because it may not always be something you want to do every time.
And just to add on to that, when you push the data back, instead of overwriting the value that you brought from the objective, it goes into the design so that you can see how you changed your model. And then it's up to the engineer to decide that that's really, the objective now, if you want to do that. But the objective usually comes from requirements. Okay, we have a few more questions. Go ahead.
Don, just to add to that is fully versioned on that parameters tab. I neglected to call that out when we were at that point in the presentation. But if that change would happen, it would be captured in the version history.
Yes, correct. Okay, well, thank you, Scott, Mark, and Mark. That wraps up the QA for today's presentation. I apologize if we didn't get to your question, but we will contact you directly to ensure that it has been answered fully. If you have any other questions or comments, don't hesitate to send us an email. You can see email addresses on the screen now for Dr. Ragon, Mark Simons, and Mark Malinoski. You can also respond to our LinkedIn group page. Just visit linkedin.com and search for Vitech Corporation. Thank you so much for attending today's webinar. Remember that at the conclusion of this webinar, a survey will open on your screen. Please take a moment to give us feedback on today's presentation or on what topics you'd like to see covered in future webinars. Once again, thank you for joining us and have a wonderful day.